Let us see student, question number 21 is asking about what voltage characteristic. Okay, general voltage regulator circuit is given and he is asking what is the output characteristic for this circuit. Okay, so this is given as this. Okay, so this is my general voltage regulator circuit. General voltage regulator circuit. Okay, so this is general voltage regulator circuit. This is my output voltage and this is given as input voltage. This is input voltage. Okay, so now this is my zener voltage regulator. Zener voltage regulator. Okay, so now we want to see the output characteristic for this, and given that the breakdown voltage for zener diode is breakdown voltage for zener diode is what, this is Vz, and forward cutting voltage for this diode is given as Vt. Okay, so as we know very well that zener voltage regulator circuit characteristic is this. Okay, and it is given as Vt, and this is given as what, Vz, breakdown voltage. Okay, this is given as breakdown voltage. Now see here, if you see here, this is what V naught. We will see what about this zener voltage regulator. Okay, so this is my current versus voltage. Okay, so now current versus voltage graph for this voltage regulator. Now see case first. So let us see for case first. Okay, case first, when case first when Vin is greater than 0 volt, when Vin is greater than 0 volt. Okay, when Vin is greater than 0 means positive. Okay, when Vin is positive voltage, then what we will see, what we will observe here, if it is positive means what, if it is positive means what, this is positive negative, opposite sign means it is reverse bias. Okay, opposite sign means it is reverse bias. Okay, if you see here negative, same sign means it is in forward bias. When it is forward bias, okay, so we will see that this diode is in reverse bias. We are confirmed. Okay, now we will see when it will go in breakdown region. Okay, when it will go in breakdown region, and this diode, when it will go in breakdown region, that time this diode will be in forward bias. Okay, when it will be in forward bias condition, the possibility, so now it is positive, it is negative, opposite sign, and it is in reverse bias. Okay, it is in the reverse bias condition. So now when it will exceed this voltage, then it will go in breakdown region. Okay, so now see, up to this x voltage, we want to check it. Okay, so here Vin. So now let us see this x voltage. Okay, x voltage, I am seeing this up to x voltage, Vin. Okay, so now let us say this is in breakdown region. Okay, this is in breakdown region. Let us say when it is breakdown region, when it will exceed this voltage, Okay, so now Vin will exceed this voltage Vz, then it will be in breakdown region. Okay, it will be in breakdown region, then this voltage will be what, Vz, then this voltage will be Vz, positive, negative. Okay, what is the value of this x is nothing but V minus Vz is equal to what, x. Okay, so this is my x voltage, x is equal to V in minus Vz. Okay, so this is my x voltage. Now I want to check for this forward bias, when this diode is in forward bias, because automatically it is in forward bias once it will go in breakdown region. Okay, so it will go in breakdown region when it is in forward bias. It is in forward bias only when x exceed this cutting voltage of this forward bias. When Vx exceed this cutting voltage of this forward bias, it will go in forward bias. Okay, so this is what x. What is x here? X is nothing but V in minus what, V in minus. Okay, V in minus Vz is equal to what, greater than Vt. Okay, greater than Vt minus means V in is greater than Vz plus Vt. Okay, so now in that case, this diode is reverse bias. Okay, this diode is in breakdown region and this diode is in forward region. Okay, so now we will see for this circuit here. This is in breakdown region and this is in forward bias. Yes, this is in forward bias. Forward bias. So this is my V in, positive, negative. Okay, this is my V out, positive, negative. Okay, so what is this VZ? What is this VT? Positive, negative. Yes, positive, negative. Okay, so now let us see. V naught is what? Now apply here KVL. We will get V naught is equal to what? VZ plus VT. Yes, VZ plus VT. This is my V naught. V naught when V is greater than VZ plus VT. Okay, when V is greater than VZ plus VT, that time V naught is equal to VZ plus VT. Okay, if okay, so this is what this. Now when V is less than VZ plus VT, then V naught is what? Then V naught is equal to, when V is less than VZ plus VT, then this diode is in reverse bias. Okay, this is in reverse bias, and this diode is also in reverse bias. Okay, so this diode does not, means if it is in the reverse bias, no current will flow through this diode. Okay, so this diode will become meaningless when it is not in breakdown region. It is not in breakdown region, because if it is not in breakdown region, this does not matter at all. This diode does not matter at all, means it is meaningless. Okay, this diode will be meaningless when the voltage across this zener diode is less than Vz. Okay, is less than Vz means it is open circuit, so it is meaningless. That time V naught is what? That time V naught is equal to V. So this means for this V, when V is less than Vz plus Vt, that time V naught is equal to V in. V naught is equal to V in. Okay, so this is the meaning. What meaning means, if this zener voltage across this zener diode, when it is in reverse bias, does not exceed this Vz, so it is in reverse bias, means it is open circuit, so it is meaningless. So V in is equal to V in is equal to V naught. Yes, to V naught is equal to V in. Okay, whatever Vt doesn't matter at all if this Vz is less than, if V in is less than what? Vz plus this less than Vz. Okay, so for this, so V in is less than, when V in is less than Vz plus Vt, with Vz plus Vt, this cutting voltage will become Vz plus Vt. This is for single zener diode. Okay, single zener diode. Now let us see for next case. Okay, first case we have seen. Now let us see for next case. Case number 2. Okay, so case number 2 is what? First case what we have seen. First case we have seen V naught is equal to what? V naught is equal to Vz plus Vt, Vz plus Vt, Vz plus Vt, when V in is greater than Vz plus Vt. Okay, Vz plus Vt, and it is V in when V in is less than Vz plus Vt. Okay, Vz plus Vt. This is for case first. Okay, now case second. Case second, if you will see, let us, when V in is negative, let us take it as, make it negative. Okay, let us make it negative. Now we will see it is negative. Okay, so when it is negative means when V in is less than 0 volt. When V in is less than 0 volt. Now we will see from bottom side. Let's see it from bottom side. From bottom side, if we will see it from bottom side, this is positive, this is negative. So opposite sign means it is in reverse bias. This diode will go in reverse bias, and this here negative same sign means it will go in forward bias. Okay, it will go in forward bias. It will not be in reverse bias. Okay, but the possibility is in forward bias. For this possibility is in reverse bias. Okay, so now once we are confirmed that it is in reverse bias, when it will go in breakdown region, now we will check. Okay, we will check it. See here, this is my Vz. Okay, so Vz means it is, okay, this is my Vz and this is my Vt. This is my Vt. Okay, So this is my current that is passing through these two diode. Okay. So now see here, when the voltage across this will exceed. Okay. When the voltage across this exceed this Vz. Okay. So this Vz, then it is in cutting voltage. Then I will represent it as V positive Vz. Okay. When I will represent it as V positive Vz only. So it is positive negative. Okay, positive negative. When I will represent it as what? Vz only when this voltage across this voltage, okay, the voltage across this zener will exceed this Vz, then it will go in breakdown region. Okay, it will, once it will go in breakdown region, now we will come to this next diode will go in forward bias. Next diode has the chance to go in forward bias. Okay, when it will go in forward bias, we will check this voltage, x voltage. Okay, x voltage, how much x voltage should be there, so that it will exceed this what, a cutting voltage of this forward bias. Okay, so now see, let us calculate first this x voltage at x. So it is v minus vz is equal to what? X is equal to x voltage. Okay, so now my x voltage is this. Okay, so it is similar to what? It is similar to the case first that we have done. Okay, so this is similar like case first that we have done. The difference is only that it is negative. Okay, it is in reverse direction. So x is this. Now we will see, when this diode is in forward bias, it is in forward bias only when this x will exceed what? Then when this exceed, when this volt, when this x will exceed this forward bias voltage. Okay, so now it is in, this is positive, this is negative. Okay, so this will act as a normal diode in forward bias, and its voltage is threshold. This is what? Vt voltage, cutting voltage. When it will exceed this cutting voltage Vt, when it will exceed this cutting voltage Vt, now see, understand, everything is what? Everything is going under negative sign. Okay, negative sign. Okay, I am not taking it negative sign. At last we will take. Okay, at last time we will take it. Okay, we will take it negative sign. Okay, so we are focusing only in positive direction from bottom side. Okay, from bottom side, x is greater than vt means what? V in is V in minus vz is greater than what? Greater than vt means what? V in is greater than V in plus vt. Okay, V in plus vt. Okay, when this V in is greater than V in plus vt, this means what? V naught will be equal to what? Now see, V in is greater than vt. Now let us take this negative sign. This is what? Minus V. Okay, now I am taking this negative sign here, means minus V in is greater than V in plus vt, means V in is less than minus V in plus vt. Okay, why I did this? Because for our convenient purpose, I started it from bottom side. Okay, then at last I took this negative sign. Okay, so now we are confirmed that V in is, when V in is less than minus V in plus Vt, this implies that what? This implies that V naught is equal to what? V naught is equal to what? We will see here what it will come. This is what? Positive negative, this is negative, this is positive, this is what? This is negative, this is positive. Yes, we are going from bottom to top. Okay, so this is positive, this is negative, positive, negative. This is Vt, this is Vz. Okay, so this is V in negative positive, and this is my V naught positive negative. So now see here, V naught is equal to what? V naught is equal to, here you will see both are this V naught plus Vt plus Vz is equal to what? 0. So V naught is equal to minus Vz plus Vt. Yes, this means what? V naught is equal to minus Vz plus Vt, minus Vz plus Vt. Okay, so this is my V naught. Okay, when V in is less than minus V in plus Vt. Now we will see when V in is greater than minus Vz plus Vt, then that time V naught is equal to what? That time this will get open circuit. Okay, this will get open circuited, then V naught is equal to V in. V naught is equal to V. Yes. So this is for next. This is for negative. Okay, negative value of V. Okay, so that we have done for negative value. This is the case second. Okay, so case second we have done. What we have done in case second is what V naught is equal to what V naught is equal to minus Vz plus Vt. Vz plus Vt when V in is what less than minus Vz plus Vt. Yes, Vz plus Vt, and it is what it is V in. It is V in when V in is what greater than minus Vz plus Vt. Vz plus Vt. Okay, so this is about output voltage for both V when V in is positive, when V in is negative. So now let us see, we will draw what characteristic graph for this. Okay, so characteristic graph for this. Now let us see, write it as, so V naught is equal to what Vz plus Vt. Vz plus Vt when V in is what V in is greater than Vz plus Vt. Yes, and here it is V in. It is V in when V in is greater than what minus what Vz plus Vt. Vz plus Vt, and it is less than what Vz plus Vt. Yes, Vz plus Vt. So this is for Vz plus Vt to Vz plus Vt, minus Vz plus Vt to Vz plus Vt, and this is minus what minus, see here, minus Vz plus Vt, and it is for what, it is for V in what, V in less than minus Vz. Okay, so it is minus Vz plus Vt when V in is less than minus Vz plus Vt. Yes, so this is overall conclusion for this circuit of given voltage regulators. Okay, so now we will draw what characteristic for output characteristic for this circuit. So we have done two cases. Okay, under these two cases we are drawing what characteristic between output voltage and input voltage. What is this characteristic? Now see here, characteristic is what, this is my V naught and this is my V in. Yes, V in. Now see here, somewhere here it is what Vz plus Vt, and somewhere here it is what negative value of what minus Vz plus Vt. Yes, Vz plus Vt. So now what we will do here, so let us see here at Vz plus Vt, what is the output? What is the output at Vz plus Vt? It is just what it is Vz plus Vt, yes. Now at minus Vz plus Vt, what is the value of V naught? Is nothing but it is what, this is nothing but minus Vz plus Vt. Yes, minus Vz plus Vt. So now here for less than this it is on. Yes, this is on. For greater than this value it is on. Now when it is between this range it is off. Means it follow the input. Output follow input between what? Between minus Vz plus Vt to plus Vz plus Vt. Yes, this is my what characteristic. This is what characteristic. Yes. So now see, this is the last, we have reached up to last answer. So answer for this what? A. Yes, A. Answer is what? A. For question number 21. Yes, the voltage means output voltage and input voltage characteristic for given voltage regulator circuit. Okay, series voltage regulator circuit. So this is everything we have done. So now we are going to next question is 22.